Here we have another example of transformation geometry. So we have a basic shape of dimensions 40 with a base of 50 overall. So what I basically got, the curve feature was got my compass, got radius 20 and marked it in here, so we have 20 and then a line of 30. Here we join this up to here when we've measured up 40 millimeters. So from point A, the first thing we're going to do is our translation. So we're going to come across horizontally, like so. And from point A, we're going to move across 150 millimeters. So here we have it. This is now point A1. So our translation is going to take place in this area. So we bring across all our points like so. And the best thing to do it, since point A to A1 is 150, our point here must also be 150. So you can use your set square to find our points. So there we go, there's that point. And then obviously this is 20. So we measure in our 20. And from there, which is like that, we can simply draw up our shape. Obviously this point joins to A, so A1 must join up there, like so. A1 must also join in here, and then finally here. A translation, all points of our object move the same distance. So A to A1 was 150. That means our whole shape must move 150 millimeters. So there you can see it. Since we're moving in this direction, all our points move this way. Since A to A1 is 150, this point here to this point here is also 150. This point here to here is also 150, making sure it's millimeters. And there you have it, our translation. For the next part, we're going to do our axial symmetry. So we're going to come down from point A1 100 millimeters or 10 centimeters. So now we can just bring across our line like that, leave it. A2 is here. So from A1 to A2 is 100 millimeters. For our line of symmetry, must be between A1 and A2. So a half of 100 millimeters is 50 millimeters. And then we get a different color pen is what I like to do. And bring it through, like so. And we can label this X, Y. And this is our line of symmetry. So in terms of literacy, making sure to know how to spell our words in graphics is important too. So we basically bring down our shapes or our points to our line of symmetry, like so, just to make sure that everything is in line. We measure from A1 to A2, that's correct. We move in here, and we get our point, and we mark it in. And then finally, get this point, mark it in. There's also other points on our shape, which is up here, and this point here, making sure to bring them all in. So then what we can do is, we can bring our line straight down through our line of symmetry. And you can see where our compass went across, and we have our points. So our shape, the bottom of our shape, this to here, is formed here. From here to here is this point to join up, and our point here and here like so. Now the final thing is we get our compass and we turn it upside down. So we were working this way, now we're working this way. So we have our points got like so. And there we have it. The difference with axial symmetry is that our shape comes through, and when it goes through our line of symmetry, it flips over, as you can see. So in terms of our compass, it's coming through, all points of our compass comes through, and it flips over as it goes through our line of symmetry and faces back. The next part of the exercise is we're going to do our central symmetry. So we have point A2, we must get point A3. So from A2 to our next point, which is going to be A3, we're going to come along 120 millimeters. Here we have it. Like so. To get our center point for central symmetry, we divide 120 millimeters by 2. So in terms of numeracy, half of 120 is 60. So I'll mark it in and label it point F. Make sure to label it. So A2 through F is now becoming A3. So now our points down here must also go through F. Every point goes through like so. Forgetting no points. Make sure to give yourself plenty of space. So as you can see, come down here, we'll mark our point. We'll mark them in. I have to extend my lines a little bit, so we'll do that now in a few minutes, but we'll mark in our lines first. This mark is here. Like so. So we'll just continue on our lines a little bit since we need to find our points. Like that. Our point here. Make sure they go through. So this is I like to, for central symmetry, label my marks. So this is A2. We'll call this B2, C2, and D2. So we have A2 to B2. So this point here we've marked is now B3. So we can draw our line in like so. B or A2 goes to D2. So here's our D. There we have it. And A goes to that. As you can see, we go so. Our D, this is D3. Good to label it. You know where you're coming then and you're going. C is this mark here. We can use our set square like so. Just label it in C3. And then finally our point for our radius is here, so we can mark it in there. And now B goes up to C, like so. So for literacy, we'll just spell out, so central symmetry. Over here we had axial symmetry, so it's important to spell our words so we can explain to someone what we're doing. And finally up here with a translation. So there you can see it, our translation shape all moves in the same direction and same length. So each line is here, in this case 150 millimeters. For axial symmetry, we must have a line of symmetry. So in this case we have a line XY. Our shape must go through this. We put our compass on all the points where it comes and meets our line of symmetry, and we swing it over. So as you can see, the marks to the compass. When it goes through, our shape flips over as it's coming through the line of mirror or line of reflection. And finally, for central symmetry, all our points must go through a point, a center point. So here we have point F. All our points, which I have labelled here for handiness of drawing, I've labelled A2, B2, C2 and D2. All must go through the point F. As you can see, they all go through, and I've labelled them over here. So when our shape goes through, it flips over and appears back to front. So A2 was once here, now it's here. B2 is here. And obviously this is our point where we can swing our arc, here. So it's the same arc for all. C is up here, and finally D, and we join up all our lines, do our arc, and we get our shape from central symmetry. So that's a transformation geometry exercise.